again.
Like quiz.
We got some great things on the show today.
It's K8BYP on a 15 meters is pretty much dead day. So let's talk about connectors, especially RF connectors and things like so-called coaxial switches. So there's PLSO connectors, and there's a old B&W coax switch, 1 in, 2 out. While the tube tester's over here cooking with the danger high voltage sign out, and the high voltage power supply is baking in and testing at 1302 volts. Pretty cool. Watch this. Neat, huh? To get from the radio transmitter to the antenna is almost guaranteed to need connectors, because the back of the radio has a SO239 most likely. As far as I know, all our amateur gear does that. And connectors are better, but we don't tend to use them. Those tend to be for higher power, higher frequency. But a couple of important points about these things. These are electrical connectors for convenience of taking a connection apart. Once we've built a station, built an antenna system, gotten things hooked up, put away, operating, we generally don't disconnect this stuff. Now, if we need to change, if we have to change antennas, change bands or whatever, here's how I do it. And that might look like a disorderly kludge, but there's a method to the madness. Because firstly, there are two L networks there for my 75 ohm antennas for 40 and 20. Just two shiny boxes, one marked 40, one marked 20, with an inductor and a capacitor inside. So that's a purpose for those, but you'll see that the cable comes in without a connector. That cable comes in, gets soldered, and there's a connector out. You can see it in the background, an SO socket. So to some extent, connectors are necessary, but it's very important to minimize them, because A, they cause discontinuities. There's no way to get a connector like that and not have reflected energy. And it doesn't take much reflected power to cause RFI in a ham shack. Fractions of a watt. I did an experiment with the Yaesu with a three-way SO connector, left one port open. It wiped out a stereo across the house. So a lot of energy coming off that open port. Secondly, is cost and complexity. Connectors cost things. These switches are popular, but they have insertion loss, they have insertion SWR. You're lucky to find one that won't present at 1.2 or 1.5 SWR mismatch. That's not good. And a better switch with perhaps more ports can easily go $300. Now, it takes nothing in a ham station with multiple antennas to get $1,000 in switches and jumper cables that are radiating trash all over the ham shack. Get rid of this stuff, you got money for a new radio. Especially if you don't buy a couple switches and don't buy a Mickey Mouse fake tuner. You got new radio money. That's money back in case lightning destroys one of your radios. And these are simply for convenience. What's important about the connectors and such is that in the old days of these PL connectors, the ends of that center conductor were rounded. See how that one's squared off and sharp? That's a bad design. Because when it plugs in, if it doesn't go in straight, it's going to gouge the inside of that female contact and scratch it up, and it's going to be a permanent arc. And that arcing can be heard by a distant operator, believe it or not. What makes the characteristic of that connector, which is supposed to be 50 ohms, like the transmission line, is the ratio of the diameters, like the transmission line, the ratio of the diameter of that outer surface of that pin, and not the shell. This shell with screw threads is not intended to be the conductor. So it creates 50 ohms is the inner diameter of this rigid outer shell, that space in between the two. That's what's 50 ohms. And so for this to make a contact without a huge discontinuity requires these being put together without damaging these inner conductors. And this thing tightens sufficiently. It's best to use a small pair of pliers to force this surface against that surface. Because if the current has to flow out and through that shield, you've got discontinuity. Because now it's defining a larger inner diameter for the outer conductor, and it's no longer 50 ohms. Amphenol rates these at 500 cycles, connect and disconnect. Frankly, 500 switching cycles on that, pardon East Tennessee allergies, 500 cycles on that box is probably going to destroy the switch inside. Inside's a flat wafer switch with spring contacts. It's going to wear the contacts and they can't be fixed. It's a problem to get a wafer switch and fix that. It's no problem to replace these $2 PL plugs. Just a little bit of time. Back of the old radio, it's very important to replace the old socket. There's a wear mechanism that isn't obvious that occurs when these are put together. When the pin is in the socket here, that force of these contact fingers, there are 4 contact fingers inside this hole, and they tend to spring inward. And there's a contact pressure between the inside surface of this and the outside surface of that. And when these are left so-called mated together, that insertion force has spread those fingers inside the socket. And that causes them to fail because they're made of springy brass. And when they're together for a long period of time, that force pushing these out tends to cause this to lose spring contact. So it's very important that these have some resistance when they're going in. It's very important to align them straight. If it just falls in, then the socket needs to be replaced. So what I've gone to doing is what, I'm not the only one, but except for this one cheap switch box I got for nothing, I'm running at low power. I use a minimum number of jumpers and I manually change them over. I want to do some quick testing and band changing, so I put this box in, but normally it's not there. It's just all this and one of those. So minimum number of connectors, minimum cost, minimum RF leakage, minimum reflected energy and discontinuity. And avoid buying these $200 or $300 antenna switch boxes, because most of the time they don't do anything. They only do something when you reach over and turn the knob. So it's a massive waste of money. Now, if you want an interesting project, and I mentioned this in my amplifier videos, but replace this, which is $200 or $300, with some cheap metal enclosure, and a handful of these industrial power relays. Get the 600 volt rated, 240 volt rated relays like this. The wide brass contact strips have minimal inductance and minimal capacitance. And you can build a remote controllable switch box with these. You might, to save space, you might get a relay with only one section. You could, at low powers we run, 100 watts on a wire, we could probably switch 4 things with this. It's a single pole. It's 4 single pole double throw, so you could throw one transmitter to 2 antennas with that. That's a similar function to this box, but these are cheap. These can be had for a couple bucks surplus, or at the most maybe $15. So you could put 4 or 5 of these in a cheap enclosure for a whole lot less money than that. And what I did in the switching unit for the amplifier was took the plastic cover off and used a relay, a double pole relay with wide spacing, and only used one contact set. That isolates these contacts so they don't couple to anything. And it only showed through 3 relays, it only showed 1.2 SWR, and I can tune that out. So there's a way to make a switch box and get as many circuits as you want, and not spend $1,000 for these commercially made Getty gadgets. So doing this, you can easily save enough money and build your own antennas to pay for the rest of the station. So here's more of an example of what amateur radio is about. Instead of just playing consumer and buying things, here's where we get ahead by doing some building things. So happy constructing. KBYP did it.